Hi, would like to show you something I've been experimenting with, a new Sentry SDK for Unity. So what I've been trying to do here is build on top of the .NET SDK that offers already a lot of features and has 5 million downloads, and recently included offline caching, which is great for mobile and desktop apps, on laptops and things like this. And the goal here as well is to configure things through the Unity editor and also to automate bringing in any native Sentry SDK when needed. For example, for this demo, I already included Sentry Android. So I have not only errors that would happen in any platform, for example, throw null in C# would fail on console, on app, iOS and Android and everything, but I included some Kotlin code and some C code that would error on Android to see the Android SDK part of things working. So if I play in the editor, for example, I can cause here the assert false to fail, and I can see on the console this is happening, right? Asserts don't get usually put into release builds, but a throw null that definitely would happen. So if you throw a null reference exception on your game, this could it wouldn't crash the game on the device, but it would error, nothing would happen. And unless you have a tool like Sentry to tell you, you wouldn't even know that this is happening on the device. So now we can add Sentry and see what happens. I'll stop the game here, and I have a Unity package that I prepared for this. So currently we're packaged as a Unity package, but we'll investigate other ways to package the game later. So it includes the editor, an editor DLL, which is what we will use to configure the SDK, the C# layer and any other native layer. So for this demo, the Android one, and the Sentry SDK itself. So we'll import this assets. So the Android SDK we use today to capture release health. So it knows when the app is on the foreground and on the background, so it can capture a session. And if there are errors in the session of the session crashes, we can tell you the percentage of your users that actually have a crashed session versus a healthy session. So this is something you get as well with the Unity SDK for Android, and the goal is to put it in other platforms as well. So now that it's installed, I can go in component, and the Sentry option shows up, and I get this window. And this is just today a subset of the options you have on the .NET SDK or on the Sentry Unity SDK. But for an MVP, it should be good enough. So if you have here DSN, and we open this new project in Sentry to copy the DSN. Of course, we will have a dedicated page here once the SDK is GA. You put the DSN here, and this is all you need to do. With this, if you build for the editor, as I will now to show you, it will already initialize the C# layer. Of course, you can opt out from capturing errors in the editor, which is this button here, because once you have everything set up, it can be a little noisy, if you will. But for us to try things out, it's really useful. So now I can play here on the editor, and I'm going to capture that same throw null here that goes to the console, right? And if I open Sentry, take me to issues, I see that error here immediately. And it tells me, it's from my Mac OS and the vendor, some tags, the stack trace, including the Unity engine frames. It includes breadcrumbs, so the logs from Unity end up as breadcrumbs that help you realize what was happening before the error happened, and some other contextual data. For example, the device, what was the battery level, how much memory it has, model, and if it's a simulator, things like this. Yeah, it was on the editor. Okay, and now if we build this game and run it on this Android device, we'll be able to test out the Android side of things. So we can switch the player to Android, and the game is deployed onto the device. And now I can cause different errors from the device, and we can see, because Sentry includes with the device information, we can see also that I'm not cheating, it didn't come from my laptop. So I will throw null from C#. It doesn't crash the game because Unity just captures all of these errors and just logs it out, which we can capture. But if I throw on the background thread in from Kotlin, then the app just disappears. And if we restart the app, because while crashing, all the app can do is just store onto disk. If it tries to send to Sentry, most likely it doesn't get there. And once I restart the game, the errors goes to Sentry. And if I go to the native crash example, well, if I can get this small button to hit, the app is also crashing. And if I relaunch it, it will make its way to Sentry through the Sentry Android SDK. So the Sentry Android SDK also bundles the Sentry native SDK that is written completely in C. So all these layers together, can capture any type of error that you can have on your game. Right, here we go. So we have the null reference here, different from the editor. It includes the zeros that still have to be cleaned up, but this is using ILCPP. Today we do not know the line number and also the module name. It doesn't include. But this is something Unity is improving on their end. So here we have, because I clicked on the no reference exception twice, I got 2 errors here. And as you can see, it did come from a Motorola phone that's also fully charged. And we can see that it's Unity ILCPP. And the time of the build and other information. And beside that, we have now an error from Kotlin. So this is the error from the Kotlin code. It includes the line number, luckily. And it has some UI lifecycle. All the things that the Android SDK can give us are included in the error. And some more device information. And finally, this is the ILCPP crash happening in C. We don't have a nice stack trace just yet. This is something that we still have to improve. But you do have, the error makes its way here. All we have to do is nicely put parse the frames and then symbolicate on the server. We also need to upload the debug symbols that the device that Unity created during compilation. So the goal for us is to make the whole experience come out of the editor. As you build the game for release, we'll also upload the symbols to Sentry, or you can use your own S3 bucket if you want, and Sentry can connect to it to pull the symbols when it needs to do symbolication. So this is it. To summarize, you install one package, you configure through the editor, you have the SDK capture any type of error from native dependencies, native plugins, or C#, and the uploading of the symbols will also be done through the editor as you compile the game, and the whole experience should be from within the editor. And we're showing these early bits for you so that you have a chance to come to us and tell us, give us any feedback if this is what you're looking for, or if you have any ideas on how we can improve things. Thanks, and see you next time.